Hey guys, so sorry I'm not at school today, but we can still learn. So after the formative quiz, which I don't have graded yet, sorry, um, you were required to do the graphing activity. The graphing activity is going to help you determine translations of exponential graphs. For number one, this y equals 2x graph, this is going to be called the parent graph or the original graph, okay? And all the other graphs that we're going to graph in this activity are based on that original. Kind of like you are based on your parents. Your parents came first, and then you came after that. So anyway, we're going to be referring to y equals 2x as the parent function. This one here. If you took your graphing calculator, you could have either substituted the x values into your function and found your y, or you could have used the table function on your calculator. Either way, this is what I found. Go ahead and check your work. The graph that goes along with this table, sorry, my graph's a little ugly here, but that's the graph that should have gone with this parent function. If you were to go ahead and do the same thing for question 2, these are the table values that I got. And this is the graph that goes along with these table values. The next question, number 3, asks you to compare the two graphs. What do you notice? Well, our first graph is in quadrant 1 and 2. And then all of a sudden, the graph travels down into quadrant 3 and 4. Well, if you take a look at the functions themselves, y equals 2x is the original, or the parent function, and this is the new one. How many spaces do you think we went down from graph 1 to graph 2? If you said 3, you were correct. So it's asking you, what do you notice about the y-coordinates? If you're not a visual learner and having a graph doesn't help you, you can also compare the y values of your table. So if you were to compare 0.25 to negative 0.275, you will notice that you traveled down 3 units. Same thing with the rest of these. Okay, so what happened was our graph translated down 3 units. Based on your answer from question 3, what would the graph look like for the exponential function y equals 2x plus 5? I think it's going to travel up 5. If you said that, you were correct. Great job. Let's go to the back side. Use your graphing calculator to graph the function y equals 2x plus 3. Kind of take note of what this exponential function looks like to the other ones we just looked at. This is the official way to write a window. The first set of brackets is your x min and your x max, and then the second set of brackets is your y min and your y max. I believe the graph looks like this. Interesting. If you were to press second and then graph, which will give you the table values, you can go ahead and look at what the table will look like. And this is what I got for my table values. Describe the differences between the graphs in question 1 and 5. What do you notice? Or what you could do is take a look at how your values change. Well, if you noticed, our graph is going to travel to the left 3. Although it looks like it would travel to the right 3 because of the plus sign, it actually travels to the left. It's opposite of how we feel. So what do you guys think for number 8? Based on your answer from question 7, what could you predict the y equals 2x minus 2 as a power would look like? If you said travel to the right 2, you were correct. Great job. Down here, this yellow box is very important. This is allowing you to write any exponential function with any translations that you want. B stands for the base of your exponential, and then K and H are how you write your transformations. So if we take a look at H, if X is being added to H, or H is greater than 0, your graph is going to travel to the left. If your H is less than 0, meaning it's going to be subtraction, your graph will travel to the right. Last but not least, if K is greater than 0, it means it's being added to your function, which means the graph will travel up, and vice versa. If K is negative, your graph will travel down. You just learned how to apply and describe transformations with exponential functions. Great job.